All right, guys, so really quickly, we're going to talk about the graphs of the inverses, and then we're just going to work a couple more examples. I had already started videoing this. However, my video got cut off and something happened. And so it just kind of, I have to restart it because it won't let me join the video. So I'm not going to erase this and start over. I'm just going to pick up where I was speaking. So what I basically went over was that the inverses, we're going to flip the coordinates for the inverse graph. So we have x comma y, and we're just going to flip it to y comma x and regraph it. Because we're looking at sine, if we're looking back to this little drawing we did, sine is only going to be from negative quadrant 1 to positive quadrant 1. That means it will only be from pi over 2 to negative pi over 2. So we will not go past pi over 2 going up, and we will not go further down than negative pi over 2, which is why our range is negative pi over 2 to pi over 2. All I've done is take the coordinates and flip them. So 0, 0 stays 0, 0. Where we have pi over 2, 1 would be 1, pi over 2. Where we have negative pi over 2, negative 1 becomes negative 1, negative pi over 2. And then we'll just stop there so it doesn't go any further. And our domain is negative 1 to positive 1 because we won't go outside of it. All right, I had just started doing the cosine where we flip. So cosine is going to be from 0 to pi. It doesn't go any further than from 0 to pi. So that's what we're going to do as well. We have 0, 1, which became 1, 0. Then we have pi over 2, 0, which is now 0, pi over 2. And then we have pi negative 1, which is now negative 1 pi. And again, it's only going to go from 0 to pi, which is why we will stop here. And then we'll talk about the domain. Domain is our x values. We are only including numbers from negative 1 to 1. All right, it won't go outside of this as far as domain is considered. And then our range is going to be from 0 to pi, and it will not go any further than from 0 up to pi. All right, the last one is going to be tangent. We are going to do the same thing here. So tangent is only going to go from pi over 2 to negative pi over 2 as well. So at 0, we have 0, 0, which will stay 0, 0. All right. It's not showing us anything else since we're not going past pi over 2. However, if I look back at some of my older stuff, give me just a second. I don't have it here. That's okay. What we know is we're not going to go past pi over 2. And we're not going to go past negative pi over 2. So at the square root of 2 over 2, if we're looking at our unit circle, what it will basically do for tangent is curve upwards, and it's not quite going to hit any of these whole numbers. And it's not going to quite reach pi over 2. So we know that's, we have square root of 3 and then square root of 3 over 3 as far as tangents. So those are going to be kind of funky numbers. We're not going to be able to plot anything really nicely on this. However, that's what it's going to look like when you graph it. The domain, however, is still going to be negative infinity to infinity because it continues on the x-axis. And then our range will, well, it won't touch, but it'll stay negative pi over 2, pi over 2. All right, so this is just a good view for you to see what those inverse graphs look like. Now let's find the exact value of a couple more examples. I am going to bring out my unit circle here. And again, you just need to think, what is the location of this? So where sine is 1/2, that's a y value is 1/2. Where's that location going to be? That's going to be pi over 6. And feel free to pause this video and work these and then come back to it and check your answers with me. I'd be happy for you to do it that way. We need to find where cosine is square root of 2 over 2, which is where the x value is square root of 2 over 2. And that's going to be pi over 4. Again, these will get a lot easier as you practice. Some of you might actually prefer it this way because it's just telling you the information and you going and finding where it's located. Now again, arc sine is the same as sine to the negative 1, square root of 3 over 2. So we need to find where the y value is equal to the square root of 3 over 2. And we've got pi over 3. All right, now we have our sign of negative square root of 2 over 2, and that's where our y value is equal to the negative square root of 2 over 2. While we are looking here, what we will find is that this location here down at the bottom is where y is negative square root of 2 over 2. However, we cannot use 7 pi over 4. We have to use negative versions of quadrant 1. So if we reflect this, it would be negative pi over 4. All right, then we have tangent negative 1. So we need to find where our y over x is equal to negative 1. Now, I know that the only ones that produce a negative 1 as tangent are going to be the square root of 2 over 2, square root of 2 over 2 coordinates because they're the only ones that match. All the rest are 0 or undefined or some funky number. So to find where tangent is negative 1, we will probably have to use this one again. Oh, wait, no. Tangent. Tangent goes across. So we'll have to use this location here, which is 3 pi over 4. Oh, wait, I messed up. Nope, this is cosine. Tangent has to go up and down. Sorry, this is why it's good to have your little notes out. So I was correct the first time. It has to be down here. So it's not going to be 7 pi over 4. It's actually going to be negative pi over 4. All right, and then we have arc cos, where cosine is equal to 1. All right, so that means that the x value is equal to 1. All right, now on that, cosine is where we use the top. So we need to find where our x value is equal to 1. And that is actually going to be at 0 pi. We cannot use 2 pi because 2 pi is having come all the way through, and we cannot come through here with cosine. All right, so we can only stay at the top. So that means it'll be at 0 pi, or you could just put 0, whichever one. And so hopefully those examples helped you.